Okay, now that we have seen how scaling functions work and how you can form an orthonormal basis at different scales using the scaling function, let me introduce what the Haar wavelet is and what is its significance. So, before we begin, let us start with a motivation to the problem. Say we wanted to isolate a short burst or spike or what we may think of as a high frequency change. We need a tool to isolate the spike belonging to some space Vj, but not a member of the space Vj minus 1. Why? Because we have to recall that space Vj minus 1 is contained in Vj, right, because when j increases we are at better resolution. Now, with this in mind, we start with the idea. So, what is the idea? We need to apply the notion of direct sum spaces. That is, we need to decompose Vj as a sum of Vj minus 1 and its orthogonal complement, and we have seen all these ideas in our lectures on signal geometry. That is, take the space Vj, decompose this space into some Vj minus 1 and its orthogonal complement, right, and what we mean is Vj minus 1 and this other space, they are orthogonal complements of each other, right, and the original space Vj is basically decomposed into these two spaces. Now, let us start with our intuition and begin this. Intuition and starting step. Consider the space V1. We need to identify a space which is, say, W0, that is the orthogonal complement of V0 with the following properties. Now, if some psi belongs to V1, this implies psi of t can be written as some linear combination of the basis in V1, and the basis in V1 using our scaling functions we can write them as AL times phi of 2t minus L, right, for some AL belonging to some real numbers. Now, psi is orthogonal to V naught, because that is how we started, right. We want to write V1 in terms of decomposition of two subspaces. So, what would this mean? This implies integral of psi of t with phi of t minus k. This has to be 0 for every k belonging to set of integers. Okay. So, we start with the space V1, we need to identify a space W0 which is an orthogonal complement of the space V0 satisfying the following properties, right. When psi belongs to V1, you can say psi can be expanded using the orthonormal basis in V1, and we said psi is orthogonal to V0. Therefore, and we know the basis for V0 would be these functions phi of t minus k. So, therefore, this function psi with phi of t minus k, this product, inner product has to be 0 for all k belonging to set of integers. Let us see how this can be done. So, we can construct psi from a set of box functions of width 1/2 and its translates, right. We can start with the box function of width 1/2 and its translates. So, if we need this condition minus infinity to plus infinity, some psi of t with phi of t dt equals 0, if this condition has to be satisfied, let us look at the trivial case of k equals 0 from our second condition, right. So, phi of t minus k, I said phi of t where k equals 0. Okay, if this has to be satisfied, a simple psi of t can be of the form psi of t is phi of 2t minus phi of 2 times t minus half. Let us get the picture here, right. If we just sketch this, this is 1 and say this is minus 1 here. This definitely is orthogonal to phi of t, which is this. You take the inner product of this with this, so you get 1, and then this is minus 1, it cancels. So, this is basically, I would write this as orthogonal to this. Now, what this means, psi of t is orthogonal to phi of t. Therefore, psi of t belongs to the space V1 and psi of t belongs to V0, right. Psi of t belongs to V0 because this space, and psi of t belongs to W, I mean W0, I would say not V1, I think this is a typo here. So, this should be V1 complement, orthogonal complement, or it belongs to space. Sorry, I think I have to, I made a small chain mistake here. So, psi of t belongs to V0 because V0 can be written as V1 plus W0, right. V0, so we start with the space V1. V1, this was written as some V0, direct sum with W0. So, basically it does not belong to V0, right. Psi of t belongs to V1 and psi of t belongs to W0. Okay. So, it belongs to W0 space because it is orthogonal complement of V0 and it belongs to the original space V1 because V1 has discontinuities at plus minus half, plus minus 1 and so on. Okay. So, thus W0 has all functions of the form sigma ak psi of t minus k belonging to the set of integers, and all these ak's are real numbers. Why? If you sort of look at the time translates. So, if you have one function which is like this 0, half and 1, and another function which is shift this function by one more time step. Right. So, this is 1 and a half, right. This is 1, this is minus 1, this is 1, this is minus 1. these two functions are basically orthogonal to each other. And you can expand this space W0 using all functions of this form in general, where this shift orthonormality holds starting with this function psi t, and we call psi t as the wavelet function. Okay. So, now we saw that we can expand a function using the appropriate basis functions in an appropriate space. In an appropriate subspace, you can expand the function using the basis for that subspace, and any particular subspace can be decomposed into two subspaces which are orthogonal complements of each other. Okay, that is the sort of the intuition where we have, and then we are now ready to discuss a general form, and I will state this as a theorem, and then we can go ahead in the go ahead with the proof in the next class. So, let us generalize this into a theorem. The statement of the theorem is as follows: let Wj be the space of all functions such that sigma k belonging to set of integers ak, that you can expand the function in this form, that is you are looking at the time scaled and the time translates of the wavelet function, ak belonging to real numbers. The first property is Wj if this is so, if Wj is a space of all functions such that this holds, right, then Wj is the orthogonal complement of Vj in Vj plus 1, and you can write Vj plus 1 as the direct sum of two spaces, which is Vj and Wj. So, this is the statement of the theorem. That means we have to prove both these properties. Okay. So, if you are clear with the intuition we had in the last step, how we were able to decompose V1 into V0 direct sum with W0, we can just immediately proceed towards proving this theorem. So, there are a few details, we will do this in the next class.